Okay, so I'm going to be explaining question 62 of section 3.4. And the question says, if h of x is equal to the square root of 4 plus 3 times f of x, where f of 1 is equal to 7 and f prime of 1 is equal to 4, find h prime of 1. So just looking at the question, we know that there's two pieces of useful information. We know that f of 1 is equal to 7, and we know that f prime of 1 is equal to 4. And it's asking us to find h prime of 1. So looking at that, we know we have to find the derivative. But over here is just a quick reminder of the chain rule, since we're going to need to use the chain rule to find this derivative. So to start off, we'll write h of x is equal to 4 plus 3 times f of x to the power of 1/2 instead of writing the square root of this in order to use the chain rule. So to find h prime of x, we know that we're going to have to take the power and bring it to the front, which would be 1 on 2 multiplied by 4 times 3 times f of x to the power of 1 on 2 minus 1. And then we know that we're going to have to multiply it by the derivative of what's inside the parentheses as indicated here. So it's going to be 3 times f prime of x. Okay. So now we're just going to simplify this equation and write it a bit more neatly. So we know that it's going to be equal to 2 times the square root of 4 plus 3 times f of x. Since 1 on 2 minus 1 is going to equal to minus 1/2, and we're going to put 3 times f prime of x on the numerator. Now we know that h prime of x is equal to this, but we need to find when h prime is equal to h prime of 1, and we know that f prime of x is equal to 4, so we can substitute that right now. So times 4. And then we know that f of x is equal to 7, so we can substitute that in as well. That's a 7. So if we simplify this or develop this, it's going to be equal to 12 on 2 times the square root of 25, which is equal to 12 on 10. And this could be simplified to 6 on 5. Therefore, our final answer is going to be that h prime of 1 is equal to 6 on 5. And that's the final answer for question 62.